Hello.
Hello. Hi, Darren. Can you hear me?
Hey, how you doing? I can hear you.
Thanks. You're loud and clear. Good. So, thanks a lot. Thanks a lot for joining in, everyone. The next session is going to be on AutoML. Darren has promised us to make a hero, you see, a ML hero by the end of this session. Okay.
Yep.
So, so
I'm gonna be
the
sharing
stage
the
is
secret weapon.
yes. You can start sharing your presentation. Um, you can post all your queries on the YouTube chat, and there will be a feedback session, feedback URL provided. It will be posted on the YouTube chat. Please provide feedback for Darren's session on the URL. Thank you, Darren. The stage is
Okay.
all yours. You can take it over.
Yes. There we go. I'm gonna share my screen. Bring it. It looks like I can't. I'm gonna need your help to bring it to the screen. Can I do it myself? It looks like I can't. Okay, there you go. Perfect. Thank you. This is looking great. Hey everyone, let me start my timer as well, just to get a sense of the time, because sometimes I kind of finish things a little bit over time, so I don't want to make that happen. Okay, there we go. Azure Community Conference 2021, and we're here in this session. And yeah, first off, our sponsors, right? Thanks for all of them making things happen. This conference, you might have noticed that there's more than 8 or 9. I don't remember the exact. We are on the 8th track. That's what I remember. So there's a lot going on in here. I don't know how many, the total numbers of sessions. I don't know what is that, but that's something crazy. The amount of speakers, the amount of sessions. And who am I? So I work for Microsoft. It's been just 2 months, by the way. I just joined Microsoft 2 months ago. So I am leading Azure application development for Microsoft Middle East and Africa for small and medium and corporate businesses. So that's a lot, I know, but simply interested in Azure application development. That's the long story short type of statement. And before joining Microsoft, I led 2 startups. I did a little bit of a consultancy as well, but during the span of 10 years, so to say, I've spent my time building products on Azure, SaaS products, multi-tenant SaaS products built on Azure platform as a service offerings. Not a single VM has ever been used, and I'm very proud of that. So that's where I'm coming from. And in this session, here's what we're going to do. I wanted to share something. Maybe you've already heard about this, obviously, AutoML. I'm sure you heard. If you didn't, that's just beautiful, because this is just session for you. If you did, still, this is the session for you, because we are going to focus a little bit from the perspective of Azure. And maybe I'm sure I'm going to be able to share some insights that you might not have, encountered so far. So the idea that AutoML is the secret weapon, and you're going to get it during the presentation, but it's like, it's an easy way out, not doing a lot of work, because that's essentially the core of being a developer, right? I mean, the reason, most of the time, the reason we write some kind of code is to automate stuff, right? Instead of us doing the manual work, we want a computer, a machine, do the work for us. And AutoML is kind of, as the name suggests, AutoML is kind of automating the process of ML. And when we do that, it helps us obviously, get rid of all of the handwork, essentially. I mean, we'll talk about the details, what I'm referring to. All of the handwork, all of the, that detailed and, time-consuming work, it helps us get rid of that. And on the other hand, it helps us, a little bit not needing to go into the very deep details of machine learning and AI as well, not really required to be an ML expert. I mean, if you are, then it definitely helps. I'm not saying it's for nothing. It definitely helps. I mean, we're not obviously in the span of 1 hour here in this session, we're not going to be covering the full spectrum of things. But if you have some ML background, or if you are willing to go deep into ML and AI, then you should still do, even if you have your secret weapon, because it's going to help you out to fine tune the weapon a little bit and get to the result a little bit faster. with that. So let me jump to the next slide. So, I mean, we did actually talk about this. Let me look at the slide. I mean, I'm using the slides in a way that those are notes for myself as well, so that I don't forget mentioning something. So, automated machine learning is the process of automating end-to-end process of applying machine learning to create, deploy, develop predictive models so that any enterprise benefits from data. Automation. It's all about automation, being able to automate. Because if you got into any ML or AI project, you know that mostly about ML in this case, you know that it's all about experimenting, right? So you got a question, you don't even know if you're going to be able to answer that. You try to find the data, you kind of discover the data, you kind of clean the data and see if you have the data, and then if you have the data that you think can help, then you run some experiments, try to figure out if you're going to be able to come up with the right model that's going to be able to help you answer the question. And in some cases, you know, the experiment fails and you go to the beginning, you either are missing some data, you either, you know, need to fine-tune the parameters for the model, and so on and so forth. So you run the experiment again and again. And to be honest, at the end of the day, you might find out that you're not even able to answer the question in hand, even though you've run a lot of experiments at the accuracy levels that you want. And this might be, again, because missing data, but this might be at the end of the day, there is the chance that you will never be able to answer that question as well. I mean, you should always keep that in mind, because, you know, maybe you need some data that's not going to be available at all, that is not possible to gather or whatever, right? So, and the other thing about AutoML is that it's a little bit of a low code, no code experience. What does that mean? So that means, I mean, there is a coding approach that I will refer to at a point. I will, you know, kind of point out how it's done, but it's not going to be the focus of the session. And overall, AutoML itself, even though you can consume an AutoML pipeline from code, the AutoML process itself is supposed to be a low-code, no-code experience where you don't have to write the code that's going to train the model and, you know, go throughout that process. And the automation is about, you know, searching for the right algorithm, because there's a bunch of them, right? Searching for the right algorithm and the right hyperparameters based on the metrics that we define. So we're going to be defining some metrics, and that's where the ML knowledge comes in. I mean, if you're very familiar with the ML concepts, then you're going to be able to find the scope of the automated search, if that makes any sense. But if you're not, then maybe you're going to spend a little bit more compute power to, I mean, in one sense, I can actually call this a brute force approach to ML. Because, I mean, yeah, let me stop there, because I got some more slides that can explain this a little bit better visually. And there we go. So this is kind of the first process. I kind of described this process a little bit. You know, we got some data somewhere. We got the data, some SQL DB, relational data, Cosmos DB, non-relational data, NoSQL data there. We might have some data warehouses with a bunch of, you know, different types of data. We might have a data lake. Some data might be on the blob storage. So long story short, we got to get those in, you know, prepare the data, right? Maybe we can use something like, in this case, I mean, this is not the focus of this presentation, obviously, but maybe we can use something like, you know, Azure Synapse to do that, clean the data, transform the data, combine the data from multiple pipelines, and so on and so forth. And then we build and train a model. So we pick an algorithm and we start building and training and then deploying and experimenting with it, right? So that's kind of the high level look into the big process. And at the end of the day, what we are trying to answer is, again, a simple question. It might be as simple as, you know, how much is this car worth? I just want to predict how much it's going to be. That's the question. I don't know if I'm going to be able to answer this question based on the data that I have. I don't know how accurate that answer will be. And based on the accuracy, I don't know if it's going to be helpful for my business or not. Because at the end of the day, we have to connect this back to the business outcome, right? We have to come up with some value to the business. And with that, let me take a look at oops, this was too much. I didn't mean to scare you guys. I just wanted to look at the chat to see if there are any questions, and there we go. None so far. Great. Oh, it looks like I forget turning on lights. There we go. Now I'm gonna look much better. Okay, cool. Next slide. So getting a little bit into the details here. So in this case, we're talking about, you know, how are we how can we predict the price of a car, right? Let's go back and remember, what was the question? How much is this car worth? And I mean, maybe we need this data to do a prediction because of, we're an insurance company or something. I don't know. So in this case, there are features that we might want to incorporate: the mileage, the condition of the car, the brand of the car, the year of make. But again, we don't know which one of these features will really be helpful to predict, or we don't know the different levels of help they can provide. Maybe the mileage is a more important factor compared to the condition of the car, but we don't know that right now, right? So, and then there's a second question that comes in: which algorithm should we use? I mean, should we use gradient boosted, nearest neighbor? What are we going to do? And this question is where this question is where the knowledge about ML helps out a little bit, right? Because you're going to see that when we run an AutoML experiment, at the end of the day, out of this brute force approach, we can actually, if we want to, we can exclude some of the algorithms, because we have a full set of features, right, that we don't know which one is going to help. I mean, we can, if we know for sure that, hey, the condition isn't going to be helpful for some reason, I know, right, isn't going to be helpful. If that's the case, right, I can definitely exclude that out of my, search. Because during the search, we will be using a brute force approach, applying all of these features and different algorithms, trying all different algorithms. So if we know that a particular algorithm isn't a good fit for what we want to do, then we can definitely exclude that. That's where the ML know-how comes in and plays. And then we decide on which parameters we want to do, how we're going to fine-tune those, and so on and so forth. So in all this work, you got to do it again and again to see the result, experiment, to find out the best that gets you the best results, right? With the highest accuracy, hopefully. And this is, okay, this is the slide to scare you off. In case you're not into ML, this is supposed to scare you out. And that's all. That is the only purpose this slide exists, just scare you off. No, another purpose of this slide is to help you love AutoML, right? Because there are a lot of different decisions, a lot of different things that you should be aware, and it's complex, right? In that complex world, AutoML really saves a lot of time. That's kind of the long story. Either you have a expertise in ML or not, AutoML is an automated approach that you can definitely incorporate into your stack of tools, right? If you don't, that's, again, it really helps you try to see if there is a brute force approach to find an answer to your questions, and we will get there. Okay, here's a different look at this, right? So we did talk about the data set, the training algorithms, and so on and so forth. So how does that all those pieces fit together, right? So this is the repetitive process, and this is manual. We got the data set. We assume that we cleaned that up. It's ready to go. We got the training algorithm, and then we got the hyperparameter values configured for a particular configuration set. And then what we do is we combine those and train the model, and then we test the model and see if it works. If it doesn't, we go back to the beginning of the process. We see again, with all these boxes, we might be missing stuff, right? We might be missing some data. We might have picked the wrong algorithm, right? We might have configured the values, wrong, or we might need to fine tune a little bit further. So, and this process is the repetitive process that we are trying to automate at the end of the day. And this is kind of the new version. If you implement automated machine learning, you still have the data set, obviously, but then you have optimization metrics, right? You decide how you're going to optimize the whole automated ML process if you want to. And if you don't optimize, what are you going to lose? The third item, we're going to put some constraints for time and cost. Because think about it, you are going with a brute force approach. You can actually go for forever, not necessarily forever. There's going to be a diminishing returns at the end of the day. And to be honest, Azure AutoML does detect that. And I guess we're going to see that. I'm going to be able to show you that because at one point, even if, here's how we approach this thing. We say, okay, here's the data. I want to do this. This is the type of question I'm trying to answer. Go. But before I tell you go and do your brute force thing, we're going to tell you, hey, this is the amount of money I'm going to spend with all this, experimentations, or this is the amount of time at the end of the day we're using CPU or GPU power. So we are telling the platform that, hey, I got 12 hours for you to go and do brute force. And out of the 12 hours, come back to me, give me your best result, and let me see what we got. That's the approach. You can definitely give, like, instead of 12 hours, I'm going to give you, 40 machines with so many hours. But at the end of the day, Azure AutoML can detect that diminishing returns, point. And it's going to tell you, like, during the last 20 runs, I didn't see, enough increment in the accuracy or whatever goal you decided to hit. So I stopped the experiment for you a little bit earlier than just keep going, because there is no value to go any further from this point down. So even though you tell Azure to go for 10 hours, it might stop in 20 minutes if it sees like there's no need, really no value enough to go forward. So that's a good thing, to be honest. So yeah, and that's going to be our approach. And how can we use AutoML, right? I mentioned that I'm going to tell you a little bit about the code, and this is as far as we go. Let me have a sip and see if there are any questions. No. Okay. In that case, I'm doing a beautiful job explaining the whole thing, right? So we got two different paths at this point: code or no code. No code means we're going to use Azure ML Studio. We will be creating our automated ML runs there. Code, which means we can use Azure ML Python SDK to consume the platform, Azure ML. Still, the Azure ML will still be the infrastructure that we will be using, but we're going to be able to configure and run that from the Azure ML Python SDK. So the only difference is, you're either doing it from a UI on the ML Studio or doing it through code, maybe in a notebook or something. Again, you are not going into the ML process and writing code to implement the AutoML process itself. No, that's not what you're doing. That's baked into the product or the service. So what you're doing is the way you consume AutoML can either be from the portal, which is what I'm going to do because it's much easier, to be honest, and it's much more friendly, not necessarily easier. I mean, if you write the code once, it's, if you got it in a notebook, it's still easy to run. But it's just more friendly visually, I guess. So that's the way I'm going to go. But keep in mind that if you wanted to make it part of a notebook or consume or, kick an AutoML run through Python, you can definitely do that using Azure ML Python SDK. Okay, cool. So, and we got different tasks, right? We got different tasks that we can do in Azure AutoML. I mean, in this case, these three are, for example, classification, regression, and time series forecasting. The example that I'm going to go, the demo that I'm going to do is going to be time series forecasting. So let's go through this for a moment, right? The main goal, for example, for classification models is to predict which categories new data will fall into based on learning from our training data, right? Common classification examples might be, fraud detection, like I have on the slide, marketing prediction, I have it all as well. Handwriting recognition is one of them as well, or object detection, right? Do we have an apple in this picture or not? So that's kind of the classification. And the regression obviously differs from that, different from classification where, the predicted output values are categorical, right? Regression models predict numerical output values based on independent predictors, right? In regression, for example, the objective is to help establish the relationship, the independent predictor variables between the independent predictor variables by estimating how one variable impacts the other, right? That relationship is what we work on when it comes to the regression. And predicting pricing is one of those. For example, for the car example, this would be a nice, this would be the right way to go. And And finally, AutoML, when it comes to time series experiment, is treated pretty much a multi-iterative regression problem. Past time series values are provided and pivoted to become additional dimensions for the regressor together with the other predictors to come out with a potentially the good result that you want to get to. So this is kind of the high level, but I guess the a little bit higher level, if you try to go a little bit higher level, what we need to understand here is, do you want to classify things? Do you want to predict a numerical number? Or do you want to forecast something based on historical data? Okay. Back from all that geek speech that I did, a little bit geeky, not that much. If you're not into ML at all, I guess this final description of, because at the end of the day, when we go into the AutoML UI, you're going to see that we're going to need to pick one of those. So the system will not be picking automatically which one you want to do. So you're going to need to pick one of those. And the high level, way to pick which one is the best is, think from, perspective of, am I kind of trying to classify things? Am I trying to predict a numerical number simply based on other attributes? Or am I trying to predict something based on historical data the data lays on a timeline, essentially. That's what it is. Okay. And with that, I was thinking I had the demo title, and I do have the demo title, Data Scientist in a Box, but it looks like I did put it into the wrong slide. Okay. So now I'm going to go out of presentation mode because I want to show you the whole story from scratch. Okay. Here we are. Beautiful Azure portal. So the first thing I'm going to do is to click on create. Hopefully it's going to work. Okay. Oops. Okay. AutoML. I will create everything from scratch for you guys. The first thing I'm doing is obviously creating a resource group. It's going to be easy. Then I'm going to go into the resource group and create a Azure ML machine learning workspace for myself. Click plus, create a new resource, search for machine learning. Okay. Create. Nice. So now I'm going to scroll down a little bit, give this workspace a name, AutoML Azure, Azure Conf. Okay, the name is not taken. That's nice. It's going to be deployed into East US, and that's pretty much it. The container registry, we don't need it right now. It's going to be created when we deploy our model. Okay, let's go and create this. Okay, once you're done with the AutoML process, you can actually go and deploy your model for consumption. You can either deploy it. I mean, you can deploy it wherever you want, but the portal helps you if you want to deploy to a Kubernetes cluster or ACI, Azure Container Instances. It does the deployment automatically without you doing anything. But you can definitely get your model out of here and deploy it wherever you want. Even export a model that is mobile compatible and run the model locally on a mobile device or something. So those are all the options that you have. There's nothing that limits you. Okay, let's wait for this. It's gonna take just a minute. Not a lot. Come on. And then we're gonna start creating our AutoML experiment. I have another environment that is ready. I mean, we're not going to be doing the whole training thing because, like I've said, it takes hours. I have another subscription where I have a full environment ready to go. I just wanted to show you the whole process of setting up things from scratch. That's why I wanted to deploy the workspace as well. Okay, there we go. It didn't take a lot, 2 or 3 minutes. Okay, let's go to the resource. And this subscription that I'm using right now doesn't have a lot of core counts. It's not a problem for this case because I'm not be running the ML experiment on this subscription. I will bring another workspace from another subscription onto the stage in a moment. Okay, it's coming. Beautiful. Cool. So as you can tell, this is Azure ML Studio. Okay. And the button that we're going to click is this big plus. No, this one, create new. Actually, we can go into AutoML and do it from there, because that's the section that we're going to work on, AutoML, and go into new automated ML1. You might think like, hey, we don't have any data. Yeah, there's going to be a wizard that's going to ask us for data. And that's where we're at. See, so this is where we're going to select a data set, but we don't have a data set. So we're going to need to create a data set. So I will click this one and say, hey, I'm going to create one from local files. And the data set name will be bike data. It's going to be tabular. Okay, next. And upload files. So I will be uploading some files from my machine here. Let's see where it goes. Okay, I got a CSV file in here. This is the one that I'm going to use. So let's click open. And here we go. The CSV file has been uploaded. Click next to see the data a little bit closer. It's parsing the file right now. And what? Okay, I'm going to try this again because this is kind of crazy. Murphy on my back. Come on. Okay, I'm going to skip data validation. Did I pick the wrong file? No. I picked the CSV file, right? Okay, I got the CSV file. What is the exact error? Authentication. You don't have permission to the specified paragraph file if you want to proceed. Do I have that data file open right now? No, I don't. That's interesting. So what if I say skip data validation? I mean, we're not going to run this experiment anyway, so it's not going to cause any trouble. But okay, these are going to be as they are. No schema to display. Okay, that's weird. Do you mind if I start this from scratch? Because I have no idea why this isn't working. From local files, sample data. This should work. Yes, this is the default, which is what I'm going to use. Okay, now, please, sir. Let me check something. I'm going to take a look at my notes. Nope. Okay, come on. Storage blob data reader role for... Oh, that's an interesting one. Okay, I can't fix this, but I'm looking at the timer. We don't have a lot of time. It's just about, I guess the workspace doesn't have the storage blob data reader role for this particular workspace. What if I take it kind of a different route? They're in simple data store. That work? Mm-hmm. Yes. Account key. Okay. I will give this a try. This is totally not planned. By default, when you create a workspace, those permissions are set up, so you don't have to worry. Trust me. Okay, let's see. Where's the storage account? And the keys. Oops. Where are the keys? Okay. Here you go. Yes, create data store. Okay, let me try that. I think this error is left over from the previous execution. Hopefully, I guess so. Because I got the preview. Why do I have 3 rows? Oh, okay. No, I have more than that. Oh, and there was a scroll. It's just it's just that I'm not used to this screen resolution. Okay, cool. Okay, we got it. Next. I'm gonna remove casual and registered because those two are being combined into CNT field anyway, so we don't have to move this in. We can exclude those. I'm gonna say next. I'm gonna say create. Okay, problem solved. For some reason, the default didn't have the permission. Refresh. Okay, we got sample data. Great. So now we can select and say next. Cool. So now is the time to create the experiment, right? I'm going to call it AutoML ASCONF experiment, whatever. Experiment. Okay. The target column that we're going to try to predict is going to be CNT and a compute cluster. So, okay. So this is where we have to create a compute cluster, which means we have to have some kind of a set of VMs and stuff so that we can use to run the experiment itself, right? That brute force will work in a compute layer. So for that, we have to create one. I'm going to click new, create compute cluster, and say, okay, I'm going to go with dedicated. I'm going to go with CPU, and this is the size that I want. General purpose D3. Okay, maybe we can use a little bit more RAM or whatever, and say next. So give a name for this compute cluster. They're in compute. Okay, here's what I'm not going to be able to do. 0 to 1 is not the best because you definitely want to parallelize the experiments. But in this case, I can't because my subscription has a limit of 6 cores because this is a very small subscription that I have here. But I ran this experiment somewhere else in a separate subscription. I will show you the results. So usually what I would do is I would go with something like 0 to 10 or 6 or whatever, right? And then you create it. So this is going to take a moment. So we are essentially creating, and because we started from 0, that means we're not going to pay for the cluster if the cluster is not being used, right? So if we don't have any experiments running, the cluster will not be used. The only drawback of that is, when you start running a new experiment, it's going to take a little bit of time to provision the initial node. And with that, okay, let's see. Let me look at the questions. Okay, I got a laugh on the chat. Things happen. Okay, this is not supposed to take this long as well. Any questions? Like I said, we're not going to run this experiment. Okay, there we go. Okay, I didn't have to fill the time. Okay, we got the compute cluster here, and we're going to select our own, the one that we just created, compute cluster, which has only one node if needed, and say next. And now this is where we select classification, regression, and time series. Time series has been already selected. It looks like the system kind of tried to predict what we want to do. And this is what we want to do. Time column will be date. Yes. Time series identifiers, we don't have to pick any for now. And auto detection, let's go with 14 for the time horizon. I don't want to go too much into, the timeline. So reading the note from here, the forecast horizon is how many periods forward you would like to forecast. I'm going to limit it to 14. And then maybe we can go into additional configuration settings. And this is where, kind of the ML know-how can help you out, right? because you can actually decide, what's going to be the primary metric for your experiment. Or do you want to block some algorithms, or are there some algorithms that you don't want to run? For example, in this case, again, we're not going to go into this, but I might want to block extreme random trees because it's not going to be helpful in this case. The other thing that we can do, and let me show you these other options as well. So again, we're not going to go into these options all because we simply can't cover it in the session, but this is where the ML know-how helps a little bit, kind of fine-tune the experiment that you want to do. One thing that is critical to set up is the exit criterion, which is 6 hours in this case. So for 6 hours, I'm going to have one node. In max concurrent iterations is 1. So, oops, what happened? No, that's not what I meant. Okay. What's happening? Scroll down. All right. Max concurrent iterations is 1. If I had, for example, 10 nodes, I could increase max concurrent iterations to 10 and have it for 6 hours. So for 6 hours, 10 different experiments will be running, child experiments will be running to find out the best approach for this. In this case, we got 6 hours or 1 hour or whatever. And then you have max concurrent iterations. So this is definitely something that you should be setting up at minimum. So that you know how long you will be running the experiment and how much you're going to pay for it. So in this case, I know how much that particular VM is going to cost per hour, and I know how many hours I'm going to run the experiment. So I know pretty much how much money I'm going to be paying for this experiment, right? So I will save this one, and when I click finish right now, it's going to start running it. And let's do it. It doesn't matter. So let's do it. We're not going to be able to wait for it because I set it 1 hour, and I'm not sure what the minimum time is. I don't think you can set it for 5 minutes for sure. There is a minimum, but I don't remember what that was. So right now we are in the automated ML run page. It says not started, but if I refresh, it's going to say starting. The first step will be most probably provisioning. Okay, it says running, but setting up the run, preparing the Docker environment and stuff. So yes, and this is going to take a while to get going. Meanwhile, I can actually show you. I'm going to bring that in. Give me a second. Here we go. Please don't crash. Okay. Okay, so this is totally a different environment. A different subscription and stuff. And in this environment, I have an automated ML run with the same data set, the same settings and all that. The only difference is that this one had a bigger cluster. Let's see. When we go to the compute clusters, yes. Right now, this is 0 nodes. But if you go in there, where was that? Okay, the maximum number of nodes is 6. The VM is the one that we picked, but this is a much larger cluster that I used for this particular experiment. And I don't remember how long I run this, but it didn't have to run the full length of the experiment that I set up. Let's go in it. Let's see what we have there. Okay, there you see it, right? So I gave this experiment too much time, and the Azure portal figured that, hey, no scores improved over the last 20 iterations, so experiment stopped early. That's good. That's good. You can definitely disable this if you want to. If you want the AutoML to keep going, you can definitely do that. But yeah, this is good. And if we look at here, you're going to see the best model summary. I mean, if we go to the models, the third tab, you can see all of the models and the different parameters that were tested. Let me try to make this a little bit smaller so that we can see all of the parameters in there. Okay, you can see here hyperparameters and the algorithm used, right? And I can scroll down and see. It looks like, considering the page sizes, okay, let's switch to 100 and see how many we have. Okay, it looks like 60 different configurations have been tested during this run, and then it came to the diminishing return point, and it stopped. And if we go into the child runs, you can see that some of these are canceled, some of them are completed, and so on and so forth. Cool. So, and if we go into the details here, we select the algorithm that won the best model, and I am assuming that you like the outcome of this. You might not, even the best that comes out of an AutoML might not be fulfilling your needs. And to be honest, it is kind of the case with this data as well, because I don't have a lot of data. So it's kind of tough. Anyways, voting ensemble, I'm going to click on it. So this is the model that we have, and what we can do. Obviously, you can see the download button, right? So click download, and you start downloading your model, and you got it. Okay. The other thing that we can do is to go and deploy. But before I do that, again, I'm not going to go into details of this because this session is not, is not supposed to go that deep. We can't do that with the time we have. But keep in mind that you can actually have explanations like, which parameters are affecting the result higher compared to the others. And see and dig a little bit deeper into the details of this AutoML experiment, right? What else should I mention? Metrics. Yeah, you can definitely come in and get those metrics as well. Look into the metrics and try to understand what you can do to improve the results. And finally, yeah, let's stop looking into those. Let's say we're happy with what we have and we want to deploy it. And you can click this deploy button. And it's going to ask you for a name. Final model. There is never such thing. Anyways, final model. Okay, it didn't like my casing. Okay, interesting. Final model, I'm not going to be deploying to Azure Kubernetes service, but I will be loaded to Azure Container Instance. And I am going to be brave and not require authentication for now for the sake of the demo. And in the advanced tab, I can enable application insights for this, enable SSL, and I can, decide, how much CPU reserve capacity I want to have for this model to be executed when it's served, memory reserve capacity, so on and so forth. So we will all leave these default and say deploy. And while that deploys, let me scroll down and go to, where was that? Endpoints. Okay. So when I go to the endpoints, we are going to see that I already have another one previously deployed yesterday night, actually. Okay, so this is, if I go into the final model, the deployment state is transitioning because it's gonna, it's gonna go a little bit faster because this is not the first deployment done by this workspace. When you do your first deployment, it has to create a container registry for you as well. So it kind of takes a little bit of a time. But the second deployment will be much, much easier. So let's go back to the bike prediction, which I deployed yesterday night my time. It's healthy. And when we scroll down, you can see the REST endpoint. So I can start sending REST API calls to this one and get some predictions. And let's do that. For that, I'm going to do something different. And let's give this a test run. I'm going to bring in VS Code. Okay, great. Open up the HTTP request that we're going to send. Cool. I have to change this endpoint with the new one that I just copied from the portal. Okay. And if my plugin works, oh, come on. The plugin that I have in VS Code decided not to run. That's an interesting one. Let me see. See, this is the second problem in this demo. There is a beautiful plugin for, I guess that was this one. Was that I really like because it helps you craft HTTP calls in VS Code. But this says install. I don't think. can't I just search in the installed ones? And let's see, scroll down. Okay, yeah, this is the one. Why isn't that working? It was working yesterday. So let's disable and enable again. Stop and start. Sometimes it works, right? Okay, let's see. .rest is the file extension that you can use, but I know there was another extension. Maybe it's in here somewhere. Oh, this is a link checker. This is not the right plugin I'm looking at. Okay, let's give this a different. No, that's not what I meant. Okay, REST client. This is the one. Great. What was the extension? Okay. See, there should be a send request button. Oh, it came in. Okay. I don't know why it was gone, but it came in. Okay, cool. So we will click this. You see this little send request button in here. I'm not sure if there's a shortcut for this button. Maybe if there's a shortcut that might work or might not. Anyways, let me click on send request, and we are sending this request to our ACI, Azure Container Instances Deployed model, and we got an answer. So here we go. Oops. Let me do this. To me, it feels like everything is going against me today. Can I close this? Okay, perfect. Okay, so we got HTTP 200, a good forecast result. So this is the result of this model. And if we look at the original CSV, I am going to open that one up. Okay, the original CSP, and remember, we are trying to predict the CNT, the count. This is the count of bicycles we expect to be rented on this particular date and time. And we got all this data to build our forecasting. And if we go to, and by the way, where is VS Code? Our request was, let's go. Okay, so what did we ask? We asked, how many bicycles do you think it's going to be rented on the 4th of August? Okay, based on this information that we have. 4th of August, 2021. So let me go to the end of this Excel sheet and see what the numbers were looking. So numbers were around 5,000, 4,000, 2,000. So somewhere between 1 to 10,000, I guess. Right? Somewhere between 1 to 10,000 would look kind of acceptable. At least it's going to give us an idea that, this whole thing is kind of working. And let's go back and see. Okay, we got 38,000. Wow, that's a little bit high, but again, not the topic of this presentation, to go a little bit deeper, kind of and try to understand if. And by the way, this prediction that we had, we already seen on the Azure portal that it doesn't have a very good accuracy, to be honest. We definitely need more data because we have a couple of years of data that ends on 2012, and we are trying to predict something in 2021. So kind of trying to predict something that happens today based on historical data that ends 10 years ago. So obviously it's not going to be a perfect predictor, but that's more of a data issue that we have here. Perfect. Okay. So that's as far as the demo goes. Hope you liked it. With that, I am actually done. So here are our partners for this conference. Thank you to all of them, helping us out, make the conference happen. And then the huge community that supports the event, obviously, that's important. And if you guys are interested in joining any of these communities, feel free to go out. If you know, it's really a good motivator, and it's really fun to join the community, whether it's a software community or something else, doesn't matter. Just go out and join the community and contribute in your own way. With that, do we have any questions? No
Hi,
questions.
Darren. Thanks for a great question.
Hey.
Thanks for a great session. As of now, I don't see any questions. People, if you have any questions, please post on the YouTube comments. Darren will be around for a few minutes. He can answer.
Yep. And don't forget to fill in the feedback form as well. It's on the chat. I noticed it was already shared. So there's a link on the chat that you can use to give us feedback about the session and the conference overall. And finally, this is how you can reach out to me if you, like I will be here for a couple of minutes, obviously. But after that, if you still have questions after the session and you want to reach out, feel free to, get in touch on Twitter or LinkedIn. And if you want to grab the deck right now, go to this URL that you can see on the slide. And you can, there is a different version of this deck because this deck is now branded with the Azure Community Conference template. You're going to see a different version of this. I didn't upload this particular version, but the content is the same. So you're going to see a non-templated generic version of this slide. But again, the content is the same. So
if you want to share the URL of the slides, you can share it, Darren. You can put it on the chat window.
Oh, so sure, it's in the slide, but I can definitely share it out on the chat too. Let me see. And copy. And I'm gonna put it on the private chat because it doesn't look like I have access to the public one. So if you can move it there, that would be great. Cool, thank you.
Okay, so thanks for the session, Darren. I think there are no questions.
Okay, yeah, thank you very much. Thank you for having me, and enjoy the rest of the conference, guys.